All right, I think we are now recording as well. So, welcome everybody. We actually have quite a bit to do today, and I'm going to kind of do the notes a little bit different. I'm going to kind of go through Desmos and do it that way. I'm going to go ahead and post the link right now.
I can hear you
Oh,
now.
oh, can you?
Yeah, I
I
found
wonder.
some headphones.
I wonder what
Earphones.
the deal was.
Yeah, I don't know. I already put in the earphones in.
Okay. Well, I'm glad you can hear.
Thank you. Sorry.
Yeah. Happens. I just posted the link to the Desmos Activity. I'm going to share my screen so that you can see mine. And I'm going to limit you first to the first screen so that we can kind of all stick together. And in modules, I'm going to go ahead and publish this too so that you'll be able to go back and look at it later. If you want to, you can write some of this on a separate sheet of paper, but it will be available to you as well. All right. I am feeling a little bit tired, but positive. And I think. All right, I see a lot of tired. I understand that. How could you forget today was Monday? In fact, I don't think I'm seeing anybody here who's putting themselves as wide awake. Did you guys just stay up all weekend and think you're going to catch up on sleep later?
Could you resend the link? It's not popping up.
Okay, no problem. It's
Thank
also available in modules, but I'll put it back in the
Oh,
meeting.
okay.
No, there it goes. Tell you what, I'm going to go ahead and go to screen number 2. On this one, you just need to tell me what you think are the key characteristics. There really is no right or wrong to this. I just kind of want to see what you put. Okay, I'm seeing people write about the asymptotes. Oh, Cooper, I like that. You put has a mirror effect over the origin. That's a nice way of saying, yeah, it's very symmetrical. I didn't put that on there, but I think that's a nice one. There's a reflection. Kayla, you put that there too. Oh, Nathan, I didn't think of it that way either. It's a rotation of 180 degrees. There are asymptotes, definitely. Doesn't appear to touch the x-axis or the y-axis. I like that. Yeah, on mine too. I put that the horizontal is at y equals 0 and the vertical is at x equals 0. And then I went ahead and put what the domain and the range were, even though you really didn't need to. The domain is all real numbers except for 0. The range is all reals except for 0. And if you haven't guessed, we are going to be talking about graphing today. I'm going to probably focus mostly on the asymptotes and some of the zeros. In the past, then we've always done, some t-tables where we sketch the graph. I'm not going to spend a whole lot of time doing that because I do expect you to probably put a lot of this into Desmos, but they don't always tell you what the asymptotes are, so I want you to be able to figure that out. So we're going to be spending some time graphing, and then we are going to take that a step further and do some solving. So give you guys a few more seconds. Put a couple more of these on. But I think what I really am looking for on this one is those asymptotes, that it's not crossing the x-axis and it's not crossing the y-axis. And remember, an asymptote is kind of an imaginary line where the graph gets really close to it but won't touch it. So we actually have two asymptotes here, a horizontal and a vertical. So if I went on to screen number 3, I'm going to go ahead and open up to 3 and 4 for you. On screen 3, I put a slider in there. Move that slider back and forth. See if you can see that relationship of what is happening. And when you see that relationship, tell me what that relationship is in screen number 4. And again, if anybody has any questions at any point, just take your microphone off mute and ask a question. I think a lot of people just put what I put, moves it right or left. Nathan got a little bit more specific. The larger the number is, the farther right it goes, and vice versa. Yeah, and I would kind of expect you to remember to do this from, we've done translations before, And I bet you probably can predict what the next two screens are going to be because there's another slider. Oops. There's another slider where I have a K. Go ahead and try that. Yeah, I'm seeing a lot of answers on that one of the K shifts the graph up and down. Moves it up and down, shifts it up and down. Yeah, if you wanted to go a step further, you might put if it's a plus sign in front of it, it goes up, minus sign, it's going to be going down. And if you look at that, that's kind of going to tell you too where that asymptote is. So if you look at the screen that I'm sharing right now, I put my K at a 2. That means that my horizontal asymptote is y equals 2 because it's getting really close to that 2. And we're going to be talking about the asymptotes a little bit more in just a second. Actually, having said that, let's go ahead and open it up to screen 7. I'm definitely going to talk about this one, but I want to see what you guys put down as an answer first. So you have to find the zeros, and then tell me what the domain is. All right, I will tell you there is only one zero on this rational function. It is not 4 or -2. So, Jelly, you've got it. Daniela, you just got it. Sylvia, you've got it. Emily, you've got it. Kayla, nice. Maria, nice. Amelia, Nathan, Emily, Emma, Nate. Ariana, it's not going to be 2. You want to take the numerator and set it equal to 0. So t minus 1. Omar, you've got it. All right, what is the domain? Um, the domain is going to be all real numbers except for 4 and -2. So, Angela, you put -2 and 4. I think I understood what you meant. All numbers except for those. Those are the restrictions. And then my thinking on that is I put something like the asymptotes occur where the graph is undefined. So that's probably where we're going to have the asymptotes as well. All right. I'm going to go ahead and open it up to 8. Hey, Nathan, are you going to fill in the blank there, or did you just leave it as a blank? On 8, I think you can actually go back to the previous screen and hit Control, highlight that equation and hit Control C. And I think you can go back and type it in. And if you notice, there are 2 asymptotes. And lo and behold, they happen at -2 and at 4. So then, I think it looks like a lot of you are still graphing, so I'll wait just a second before I talk about screen number 9. So what I'm trying to get you to realize on this one is wherever your graph is undefined, or like when you find the domain and it's all real numbers except for -2 and 4, that is where your asymptotes are going to occur. They're going to occur at, in this case, at -2 and at 4. And you can, if you go back to the where I'm sharing my screen, you can see where that exactly is happening. -2 and at 4. So that graph is going to get really close. And we found our 0 at 1, which is right here. Oops, there. And as I said, I'm not going to spend a lot of time on graphing because I'm just expecting you to use Desmos since it is such a easier tool than making a t-table. But in the past, what I've made students do then is plot a couple numbers to the left of their asymptote, in the middle of the two asymptotes, and to the right of the other asymptote. And then you just sketch based on what your t-table is. Okay? So I'm going to go ahead and open it up to screen number 10. On this one, you might need to do a little sketching of your own. And I have found that the middle button where you can actually do a straight line is a little bit easier. So go ahead and tell me what those vertical asymptotes are. And then come up and tell me what the domain would be as well.
It's not letting me access screen 10.
That's because I forgot to hit the plus sign. Thank you.
No problem. Thank you.
Thanks for letting me know. Otherwise, I was going, why is it nobody on 10 yet? Thanks. Okay, I think on this one, we're going to need to talk a little bit more about that one. Tell you what, you might need to toggle over to go from the Desmos Activity back to the Google Meets so that you can see my screen a little bit better. And I'm going to show you my thinking on this one. Is what I did was I drew in my vertical asymptotes. So I have 2 of them. And I kind of had to guess where that one was, but it looks like they're counting by 2s. So I said -5. So that's where I got the x equals -5. And then I drew in my other one. And and again, they're counting by 2s. So I put x equals 2. I saw a couple people who put in 1, and I understand where that thinking comes by, but look and see what they're counting by. So I put all my vertical asymptotes are at x equals 2 and x equals -5. That means my domain is going to be all real numbers except for 2 and -5. So it's going to be all real numbers except for 2 and -5. All right, looks like a lot of people corrected that. What I really want you to get out of that is your vertical asymptotes are discontinuities that are happening when the graph is undefined. Pa, you just changed yours. Did you get -6 instead of -5? I'm okay with that. Omar and Nathan Smith, I think you missed a negative sign on your -5s.
Miss Wheeler,
Yeah.
is there any specific way you want us to say all real numbers, or can we just abbreviate it or something?
If I were writing this, I would use that funny looking R.
Yeah,
It,
but for Desmos.
no.
Okay.
You can put any. See ARN. That's fine. I don't know how to do that symbol in
Okay.
Desmos. There might be a way. I don't know it. So any way that you want to.
All right.
Thanks for asking, though. All right. Let's talk about horizontal. All right. I'm going to go ahead and open up the next two screens. And on screen 11, you're just going to see some sliders. And unfortunately, there's no way to put the graph and the questions on the same page. So you're going to have to kind of go back and forth between 11 and 12. And I'm going to kind of tell you what I'm looking for on both of those. So if I go to 12, and I want to use the previous slide to make A equal to B. And what do you notice about the horizontal asymptote? So if I make A and B the same number, my asymptote is going to be C. Oops. So if A equals B, horizontal asymptote is C. And then we want to go to the previous slide and make A bigger than B. So A needs to be smaller, B is bigger. And if I just slide that along, what I notice is I don't have one. So if exponent A is larger than exponent B, there is no horizontal asymptote. And then our last one, we want A smaller than B. So I'm going to go back. And in this case, I'm going to make A smaller. And it's going to do some weird things on the graph. But one thing that stays consistent is it doesn't cross the x-axis. So that means I have a horizontal asymptote at y equals 0. So if A is smaller than B, the horizontal asymptote is at y equals 0. And I'm going to leave that up there for just a second in case you want to do that, or if anybody has any questions on any of it, because it's actually 3 important pieces of information there. And we'll be going over this again on Thursday. I'm going to there's a lot of information going on here today. All right. And then the last thing I kind of wanted to talk about was solving, and we'll see how far we get on solving today. If we don't finish up on everything on solving, that's fine. We can finish it up next class period. So I went ahead and opened it up to screen number 13, lucky 13. So if I look at this and I said, what is the common denominator? I've got 6x squared, 3x squared, and x. My greatest common denominator, or my least common denominator, I'm sorry, would be 6x squared. So 6x squared. Because all three of those terms can be divided into 6x squared. Well, our goal here is we want to solve this problem. So what I'm going to do, and you might, if you want to just watch on the Google Meets versus actually doing this one, I would understand that. Or if you just want to take notes and you can fill it in later, I'm fine with that too. So what I would do then is multiply each term by 6x squared. That's supposed to be a squared there. I apologize for my handwriting. And then what's really nice is I'm going to change colors. Things cancel. The 6x squared and the 6x squared cancel, and I'm left with 1. 6x squared over 3x squared is just going to be 2. So then 1 times 2 is 2. 6x squared over x, one of my x's is going to cancel, and I'm going to be left with 6x. And I had to make a separate box because I knew we would run out of room. So I've got 1 minus 2, or 1 equals 2 minus 6x. That suddenly becomes a very solvable problem. Subtract 1 from both sides. Divide by -6. And remember, a negative divided by a negative is a positive. So that is my final answer, 1/6. And I always kind of want to go back to the original problem and make sure that that won't result in a 0 in my denominator. It's not one of my restrictions. So I'm good. I am done. The key on solving these rational equations is to try and get rid of the denominator. I'm going to do one more example. And again, if you just want to follow along on the Google Meets and write it down, and you can do it later, I understand. It's hard to write on using a mouse pad. So on this one, I have 1 over n minus 8 minus 1 equals 7 over n minus 8. My common denominator is just n minus 8. So what that means is I want to take each term and multiply it by n minus 8. Is there a question?
I can't get to the next slide.
That's because I forgot to hit the plus again. Tell you what, I'm going to go ahead and open up everything so that I don't keep on forgetting to do that, okay? Thank you for letting me know. And then multiply that middle one by n minus 8. Oops, let's try and do that a little bit neater. And multiply my last term by n minus 8. The biggest mistake I see people make on this one is forgetting to multiply your middle term by the n minus 8 because there's no, it's not a fraction. Now, this is my favorite part, is when we get a cancel. N minus 8's cancel, n minus 8's cancel, and I'm left with 1 minus, and I'm going to keep this in parentheses because I'm subtracting that whole thing. And then it just becomes an algebra 1 problem. So we have 1 minus the quantity, n minus 8, equals 7. So 1 minus n plus 8. Combine your like terms. Know that n is going to be 2. Let's try and make an equal sign. That looks like an equal sign. Then I like to go back to my original. It's not going to create a 0 in the denominator. I am good. We are going to be spending more time talking about solving these, and I think on the last screen I said, due to the limited class time, I'd like to give more examples. However, there are more examples are on the videos on the Canvas page. I am kind of curious to see what your holiday movies are. I'm going to type mine in. Home Alone? No, 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 no. How many? Too many people are putting Home Alone. Cooper, I almost put Die Hard. The Year Without Santa Claus, I don't think I've heard of that one. Okay, Daniela, Rudolph the Red-Nosed Reindeer as a kid used to scare the living bejeebies out of me. I don't know why. Emily, I'm with you. I've never seen Polar Express. Christmas Vacation. That's a classic. I like that one. I almost put that one. Nobody else has put down A Christmas Story? You'll shoot your eye out? Maria, I don't know Holiday. Just saw The Grinch. Okay. I'll tell you what, this is the end of the part that is required. I'm going to stay online and I'm actually going to do some of the homework problems. So if you want to see more of the solving, stick around. So I think I actually even brought up these problems. It says the file is locked. Oh my goodness. What is going on? Let me see what I can do about that. Let me go to... Obviously, it is very much of a Monday for me. Hmm. Shouldn't be locked. Tell you what I'll do is I'll just repost them as a picture. Sorry about this, folks. For that, oh, just a second. We need to save it. Try hitting refresh and see if that link works. Daniela, are you still there? It did work? Okay. I guess this is what you guys get for being first period on a Monday. All my mistakes. Sorry about that. Let's go ahead and start working through some of the problems. So if you noticed, problem number 1 was one that we actually did in class. So I'm going to go ahead and start with problem number 2. On that one, my GCF is going to be, or my lowest common denominator is going to be 2n squared. So I'm going to multiply each term by 2n squared. And then what's going to happen is I'm going to be able to do some canceling. The n squared cancels with the n squared, and I'm left with 2 times 1, which is 2. One of my n's cancels, and I'm left with 2n times 1, which is 2n. And then my 2n squared cancels, and I'm left with 1. So then just subtract 2 from both sides. Divide by 2. And I get negative 1/2. So that works. Let's go ahead and do number 4. I think that one's a little more involved. On that one, my common denominator is going to be 4b squared. So that means I need to multiply each term by 4b squared. So I'm going to have that times 4b squared. The 3 times 4b squared. And that term by 4b squared. And it's 4b squared because each denominator can be divided into that. Now I get to do my favorite part of canceling. So the 4b squareds cancel. And I'm just going to be left with b plus 6. Uh, 4b squared over 2b squared goes in there 2 times. 3 times 2 is going to give me 6. And then 2b squared and 4b squared goes in there 2 times. And I'm going to be left with 2b plus 4. Combine like terms. Distribute. I'm going to subtract b from both sides. So 2b minus b. Then I'm going to subtract 8 from both sides. And I got that b equals 4. All right, let's look at number 5. On 5, I'm going to multiply each term by 5x. And that is going to give me, oops, I'm going to do that in another color. My x is going to cancel with that x, and I'm going to be left with 5. 5x's cancel. I'm left with 6. And I'm going to let you guys finish that one on your own. I want to talk about 7 and 8 because those ones are a little bit more involved. If I took v squared minus 5v and I factored that, I would get v minus 5 or v times v minus 5. And that's actually going to be my greatest common factor, my lowest common denominator, because there's a v here. So I'm going to multiply and I'm going to leave it in the factored form. And it gets a little bit messy because there's so much going on here. V plus 5 minus 5. And I'm going to multiply this term by that, which is v minus 5. v minus 5. Which works out nicely for these because those two are going to cancel completely. And on this one, It's just the v that cancels. So I'm going to be left with v minus 5 plus 3v plus 12 equals 7v minus 56. And again, I'm going to let you finish solving that one on your own. On 8, I'm going to take that m squared minus m and factor that. M squared minus m is going to give me m times m minus 1. So I'm going to multiply each factor times m minus 1. And that cancels. So I'm left with 1. That m cancels. So I'm left with m minus 1. And that one cancels, and I'm left with 5. Okay. Number 9 should look pretty familiar to you. 10, I'm going to let you work that one out on your own completely. My advice is to factor that middle term before you do anything. Okay? I am going to be on here for the next 15 minutes, so if you want any questions, just ask.